Hello students, come to the second lecture of Poisson distribution. What is the first question? Today's first question. If the probability that an individual suffers a bad reaction from a certain injection is 0.001, determine the probabilities that out of 2000 individuals, number 1 exactly 3, more than 2 individuals, none, more than one individuals suffering a bad reaction. Did you understand the question properly? Let's see again. If the probability that an individual suffers a bad reaction, see, everyone is suffering with a some reaction from a certain injection is 0.001. See, individually suffering with some reaction, so to suffering that reaction there is a probability 0.001. what can I say? Given you the value of p here, suffering with a bad reaction. Yes, so P equal to 0.001 he mentioned in the question. How many members are suffering? 2000 members are suffering, which means N equal to 2000. Okay, right. Now, number 1 exactly 3. Number 2 more than 2 individuals. Number 3 none. Number 4 more than one individuals are suffering with a bad reaction. Like this question is belongs to the Poisson distribution, right? So to finding a Poisson distribution sum, we required only lambda to finding the Poisson distribution. Am I correct? Yes, we need only the value of lambda. But I got a value of n and p. If you see the previous two sums, see the first question of Poisson distribution given you the average. Come to the second question, here also given you average. Yes, but coming to the third question, he did not given the direct value. I mean, average value did not mention. He given you the value of n and p. So can I say we have to find the value? We have to find the average first of all. Yes, we have to find the average. Then how can I find the average in the Poisson distribution? And I already told you the formula of the mean is lambda, or we can also say that n into p. Yes, mean of the Poisson distribution. So I'm using this n into p formula here. Mean nu equal to lambda. We can also denote it as n into p. So 2000 into 0.001. Then my multiplying with this, I'm getting the value of mean average lambda equal to 2. Okay, so this is my average in this question. So now what is asking to find in the first question? Exactly 3 members are suffering with a bad reaction. So how can you denote in the probability? P of x equal to 3, because exactly 3 members are suffering, right? So P of x equal to 3. Then what is the Poisson distribution formula? P of x equal to e to the power minus lambda, lambda power x by x factorial is the formula, right? So in this formula, wherever x substituting 3 and in the place of lambda substituting 2, so e to the power minus 2 into 2 to the power x is nothing but 3 by 3 factorial. Then what will be the answer for this? 0.1804. Okay, see, This is the probability for suffering exactly 3 members out of 2000. Okay, right. So second question, more than two individuals are suffering with a bad reaction. So more than two individuals, can I say 3 members, 4 members, 5 members, up to the 2000 members? Yes, because in the question given you more than two individuals are suffering. So I we can denote it as P of x greater than 2. So P of x greater than 2 means what are the values of x here? X equal to 3 plus P of x equal to 4 plus so on plus P of x equal to 2000. Okay, see, now I have to write at every value of x, at every value of x, Poisson distribution. I hope it is very difficult to find because 3, 4, 5, so on 2000. At these all the places we have to find a Poisson distribution. So instead of this very lengthy concept, I'm going indirect way. What does it mean by the indirect way here? We know in the probability, the total probability is 1. Okay, so from this total probability, I'm removing unwanted values. So what are the values are we required? 2, 3, 4, 5, no, no, 3, 4, 5, so on 2000. Then what values we does not require? Tell me. P of x equal to 0 and P of x equal to 2, right? uh, X equal to 1 plus P of x equal to 2. See, these three values are not required, so which I am eliminating from the total probability 1. Then I will get the actual probability 1 minus of, at x equal to 0, what is the Poisson distribution? E to the power minus lambda, lambda nothing but 2, into 2 to the power x, it is 0 by 0 factorial plus, similarly at x equal to 1 and at x equal to 2 we'll write it now, e power minus 1 minus 2 into 2 to the power of 1 by 1 factorial plus, similarly at x equal to 2, e power minus 2 2 to the power of 2 by 2 factorial. Okay, now what is the solution for 0.3233 is the solution. Okay, right. So third one, none, which is nothing but no one is suffering with a bad reaction. So no one is suffering means what is the value of x here? 0. So at x equal to 0, we'll find a Poisson distribution. E power minus lambda is nothing but 2 into 2 to the power x. So x value is 0 by 0 factorial. Then what is the result? 0.1353. Okay, now we'll see the fourth question. More than one individual suffering a bad reaction. So mean 2 members, 3 members, 4 members, so on 2000 members are suffering, right? So P of more than one individual, x greater than 1, it is equal to x equal to 2 plus x equal to 3 plus so on plus P of x equal to 2000 I think this is also very lengthy to finding, right? So for here also applying the indirect format. So what is the indirect format? From the total probability 1, I'm eliminating which we don't require. So what are the not required values we are having? P of x equal to 0 plus P of x equal to 1. Yes. So now at these places I'm going to writing Poisson distribution. Right. So 1 minus of at x equal to 0. So e to the power minus lambda. Lambda value is 2. So minus 2 into 2 to the power of 0 by 0 factorial plus e to the power minus 2 into 2 to the power of 1 by 1 factorial. Okay, so now by calculating it we are 0.594. So I hope everyone is clear with this question. We'll see the next question. A manufacturer knows that the condenser he makes contain an average 1% defectives. He packs them in a box of 100. What is the probability that a box picks at random will contain 3 or more faulty condensers? Right. So what is the given values? A manufacturer knows that the condenser he makes contain an average 1% defective. Right. So what will be the p value here for 1% defective? So can I say p equal to 0.01? Yes. And he packs them in boxes of 100. So in 100 boxes, those defective things, defective condensers are adding. Okay, right. So if you observe again in this question also given not given you average, so we have to find the average, right? So mean mu equal to lambda into p, it is equal to 0.01 into 100. Uh, Therefore mu equal to 1. Okay, so which means lambda is equal to 1, right? So to finding Poisson distribution we need a lambda, and that lambda value we got it now. So now coming to the solution, what is asking here? What is the probability that a box picks at random will contain 3 or more faulty condensers, right? So how can I denote here? P of x greater than or equal to 3 condensers, right? So in a box it is containing 100 condensers. In that 100 condensers, what is the probability of getting 3 or more faulty condensers? That we have to find. So that's what we can denote as P of x greater than or equal to 3. So P of x equal to 3 plus P of x equal to 4 plus so on plus P of x equal to 100. See, so what I'm doing now, at every at every value of x I'm writing Poisson distribution. I think this is also somewhat difficult to find at every value of x. Yes, so I'm finding the indirect way. What is the indirect way? From the total probability 1, I'm eliminating which we don't require in the question. So what are the values we don't require? P of x equal to 0 plus P of x equal to 1 and plus P of x equal to 2. See, these values are not equal. Okay, I mean not necessary, right? So I can denote it as 1 minus half p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2. So 1 minus half at x equal to 0, e power minus lambda. Lambda is nothing but 1 into 1 over x. It is nothing but 0 by 0 factorial plus, now substituting at x equal to 1, e power minus 1 into 1 power 1 by 1 factorial plus at x equal to 2, we'll see e power minus 1 into 1 power 2 by 2 factorial. Okay, right. So now by calculating this 0.0803. Okay, see, this is the probability getting 3 or more faulty condensers in 100, in the box of 100 conditions. Okay, I hope everyone is clear to you. Now we'll come back to the next lecture.